Okay, good morning, everyone. Thank you so much for coming early today. We're going to get started. I know we're starting about 10 minutes late, but we wanted to give time for people to filter in. So I'm John De La Parra. I am director in the Food Initiative at the Rockefeller Foundation. One of the projects that we have prioritized over the past 3 years since I've been at the foundation is the Periodic Table of Food Initiative, which you're going to hear a lot more about today. And in just a minute or two, I'm going to pass it to Selena Ahmed, who's the global director for the Periodic Table of Food, who will explain all the details of what it is. But I just wanted to set the stage a little bit of, our motivation for this project and why we think it's important, and especially the intersections with the work that you all are doing all around the world. So at the foundation, about a year ago, we announced that we will be shifting 100% of our work towards climate work, which is really exciting for me, and it should be exciting for the world to see a foundation that is founded on oil money to now be divesting from oil investments completely and shifting all work towards climate action. And as part of that work, I think the Periodic Table of Food plays an important role. Essentially, what the Periodic Table is an effort to develop standardized, comprehensive metrics for food composition in ways that we haven't seen in the world before, in ways that can be cross-compatible and created in any part of the world, as long as they have certain instrumentation, which are the types of capacity strengthening that the Periodic Table is also providing. So we kind of think of it in 3 buckets. The first bucket is developing technologies that will allow us to look at food composition in greater detail than we ever have before in a standardized way. The second bucket is capacity strengthening, as I mentioned, and we have, and Selena will show you, we have many centers of excellence all over the world that will be generating food composition data from their unique biodiversity and their unique cultural viewpoints. And the third bucket is demonstration projects. So why should anyone care about food composition? And the way that we're doing that, and the way that the foundation has been funding that, has been by selecting specific projects around the world that show how variation in food composition can be tied to, for example, different agricultural practices. And that's actually been a big focus of the work that we've been doing. So we've been developing projects that show, well, if I were to grow my food in using traditional ecological knowledge or agroecological methods or regenerative agriculture, how do the qualities of those foods change compared to conventional agriculture? So that's a few of the things you're going to hear about in this session. You'll also hear from Chef Alejandra Schrader, who we're also analyzing her food. You'll hear more about her work in the session after the coffee break. So if you're looking at the schedule, we've made a slight shift. So Chef Alejandra will not be speaking in this before 10 o'clock, but after 10:30. So stick around for that, and that's when the tasting will be as well. All right, I'm going to pass it to Selena now, who is our global director at the American Heart Association.
Good morning. I am so happy to be here today and sharing our journey of where we are with the Periodic Table of Food Initiative. We'll be launching our global database in about a year from now. So really happy to be giving sort of a sneak peek of the data that's emerging and also ways that all of you can get involved. At the Periodic Table of Food Initiative, our ultimate goal is to enable stakeholders throughout food and health systems to use data to lead data-driven solutions for advancing human and planetary health. And this is why we're so pleased with the conference theme that's focused on human and planetary health. We really see food as central to the biggest challenges of our time, both the challenges, but then also solutions. And so coming to this conference, it was really nice to be celebrating this theme. And I know as ethnobotanists, as ethnobiologists, so many of the communities that we have worked with or are working with have long celebrated that theme. And it's really, when we're thinking about the global dialogue on human and planetary health, often the voices of ethnobotanists and ethnobiologists and the communities that we're working with are not represented. So it's really nice to see the linkages that we can make with our work in ethnobotany and this more global dialogue and framework. So we have three questions that we ultimately seek to address with the data that we're generating at the Periodic Table of Food Initiative, or the PTFI. The first is, what is in the food that we eat? And this is a comprehensive understanding of all of the biomolecules in food, the thousands of compounds in food. And then how does this composition vary based on how food is grown, whether it's grown using smallholder mixed cropping practices, regenerative agricultural practices, depending on when it was harvested. We really want to understand the drivers of variation. And this morning, Kat and Sarah Brinkley will be sharing a little bit more about that and how we're capturing that data. And then ultimately, what are the implications for people and the planet? So really taking this data to drive solutions with stakeholders. We are addressing those questions with three open access offerings that we are providing to the world and different partners. So the first are tools, and these are multi-omics tools to comprehensively understand everything that is in food. Data. This is data on food composition in its totality. Standardized data that's coming from our standardized tools, as well as associated metadata on the cultural, economic, human health, and ecological attributes of food. And then ultimately enabling stakeholders throughout the food system to use this data to drive solutions through training. And this is an open access platform that we're developing called Good Food U that I'll speak about in a bit. And so we start with a very basic question at the Periodic Table of Food Initiative. What is in a tomato? What is in a tomato? Lycopene, yes, so some phytochemicals. What else is in a tomato? Seeds, yes, some plant parts. Vitamin C, excellent. Organic acids, excellent. So depending on how you answer it, sometimes people will say there's the sun, the soil, clouds, rain, right? All of the elements of the earth have come together to provide the tomato. And then what we're focusing on are all of those elements as well as the composition of what's in it. When we look at traditional databases, national food composition databases, they have about 35 components of what is in a tomato. When we look at the scientific literature, it's several hundreds to thousands of components that are in that tomato. And so we know there's a big gap of what's in the scientific literature and what are in databases, national food composition databases. And at the Periodic Table of Food Initiative, we're trying to fill that gap of using those cutting edge multi-omics tools and having that data available in a centralized database. So in addition to the macro and micronutrients that are usually in food composition databases, we also want to provide quantification and identification of the thousands of other compounds that are in our food. A lot of those are the anti-inflammatory compounds that we recognize as specialized metabolites. In addition to what foods produce innately, we're also interested in the exogenous compounds that enter food through food supply, through production practices, through processing. These are both natural compounds as well as synthetic compounds. So really having a comprehensive understanding of the good and the bad that is in our food. And then very importantly, how does this vary with our agricultural practices? So we can really then begin to design solutions for people and the planet. When I ask you what's in a tomato, you might say, well, what type of tomato? So we know there's all of this diversity of genetic diversity and based on the environment where tomatoes are produced. And so we're trying to capture this in our database as well. A lot of food composition databases might have one or two samples, but we really want to study the incredible diversity that we see in our food. You also might say, how and where was the tomato grown? We know scientific evidence suggests that there's notable significant differences in key components of food based on our agricultural practices. However, with different scientists using different tools and approaches to understand what's in food, it's very, very hard to compare that data to actually look at trends across research studies. And so for the Periodic Table of Food Initiative, by having standardized tools, we're actually going to be able to answer these questions because the data will be harmonized. So this is really groundbreaking. Looking at the scientific literature, for example, this meta-analysis, it's looking at studies that are all using different tools and approaches to understand what is in food. And it makes it really hard to compare between studies. But if we're all using the same protocols, the same tools to understand what is in our food, we can begin to make those comparisons. So this is a really, really exciting frontier of science and of food composition. In addition to the known components in food, for tomatoes, we also know there's thousands of unknown components. And so our preliminary research looking at cross-sectional data that's coming out of the tomatoes that we're analyzing are showing thousands of signatures that are of unknown components. So in addition to the known components, we're also providing a discovery platform to enable scientists to begin to explore what these unknown components in our food are. And so what we see ourselves as is a bridge between traditional food composition databases that have standardized tools, that have data that's harmonized across studies, across labs, as well as having that data available in a centralized database. And then also the novel multi-omics approaches that are emerging that really enable us to understand comprehensively what is in food. However, there's a discrepancy between these two approaches where there's standardization for national food composition databases, and then for the new multi-omics tools, each lab is using their own protocols. As a graduate student and as a postdoc, so much of the work that I did was developing multi-omics protocols for a specific food. And then I moved to another lab, and it made it really hard for me to compare the data between studies, between labs, as we're always doing method development. And so what the Periodic Table of Food Initiative is doing is providing standardized tools for the global community, for all the foods in the world. And so we have standardized ways. And so we can all put our data together in one database, in addition to the scientific literature, and we can really begin to compare our data and understand the drivers of food quality and really improve our food supply and that quality. Key to what we're doing is understanding the metadata, and Sarah and Kat will be presenting on that shortly. So in addition to knowing what is in food, we really want to understand how that varies based on growing practices, based on climate change. In the future, we are probably going to be the world's biggest database that tracks how climate change is impacting food quality and food composition. Also understanding all of the cultural attributes that are linked to food quality, the fermentation practices that ultimately influence what we're eating and the attributes it has for us and the planet. And what are the foods that we are analyzing? As an enabling platform, these are the foods that folks around the world are interested in studying and contributing. So this is an open access participatory database. And one of the reasons that we're here at this conference really is to engage with this community for your participation in analyzing foods and contributing the data. And so we carried out an analysis just to begin to understand the data gaps of food composition data. And we had experts around the world, and some of you may have contributed to nominating foods. And we got about 1,600 foods that were nominated from experts around the world. We call these inspirational foods. These are foods that have unique attributes. They might be foods that are commonly consumed in diets, or they may be underutilized crops. But these are all foods that folks think are really important to consume. And then we looked at existing national food composition databases to see how many of those foods actually have data. And we found that less than 400 are represented in many national food composition databases. So there's a big gap that is really, that exists in our current understanding of food, and specifically that data which is accessible to people around the world through open access databases. And so we're trying to fill that gap by analyzing these inspirational foods, but we're not going to stop at this list. The goal is for this just to be an inspirational list, and for our partners around the world to profile their edible biodiversity of the foods that you all find valuable in your communities. So we know what we're doing is very ambitious and that we cannot do it ourselves. We are thus building a global ecosystem of partners around the world. We are working with centers of excellence, one on each continent. In addition, we are beginning to work with one national lab in each country. These are the labs that lead food composition analysis for their countries. And the goal is to work with every country over the next decade to generate national level food composition data. In addition to having data on what is in food, we also anticipate researchers to utilize the multi-omic standardized tools that we're developing for their research projects. Many of you know the work of Alex. We are supporting a demonstration project that he is leading in the highlands of Ethiopia, looking at mixed crop systems and really understanding the food composition of these unique mixes, and then linking that to how those foods and grains are grown in these very agro-diverse, biodiverse systems. And then sort of in terms of capacity strengthening, we know that the data that we're generating is more data than the world has seen before and will know what to do with in terms of developing solutions. So I'm really excited to share that we will be launching Good Food U as an open access educational platform to translate the cutting edge research and data, not just from the Periodic Table of Food Initiative, but from other research initiatives, and translate that to think about how do we actually develop solutions that producers, that chefs, that folks that are involved in food procurement, that scientists, that crop breeders can use to really inform programs, practices, and policies. Just wanted to share where we are in our journey. So the PTFI was initiated or sort of was incepted at the Rockefeller Foundation, probably earlier than 2019, but I'm putting 2019 here on the map. And then in 2021, the American Heart Association, where I'm based, and Bioversity Alliance was selected as the co-secretariat to manage the Periodic Table of Food Initiative. And that's a really exciting collaboration. It's taking a leader in human health with a leader in planetary health and agriculture and bringing us together to really think about this initiative in a very holistic way. So we've been managing the Periodic Table of Food Initiative since 2021. And this month, we are really excited. At the end of the month, we will be having a data preview where we will be sharing sort of a sneak peek of our data and getting input from stakeholders. And I'll share 1 or 2 slides of data here today as well. And we will be launching our database next March. So right now, we're really just sharing where we are on our journey. And we're also beginning to distribute our standardized multi-omics tools to partners around the world. So any of you who have high resolution mass specs on your campuses or in your labs and are eager to onboard our multi-omics tools, please email me and we can begin to see what sort of process that will involve. Okay, so we're going to shift a little bit in thinking about what sort of questions PTFI data will enable us to answer, and then look at a little bit of data, but understand the tools a little bit better as well. So 2 questions for advancing human and planetary health. Theme of this conference: how do we grow food in ways that are good for both people and the planet? How can we adopt growing practices to improve human and planetary health? And just wanted to pause and, again, answering these questions. Again, this is a participatory effort. It's an enabling platform. So it's really to enable researchers around the world to answer these types of questions. And so you can utilize the data that is going to be coming out of the PTFI because it will be open access, except we have some considerations for Indigenous data sovereignty, and also to be onboarding the tools in your labs if you have labs on your campus, or if you have your own lab. Also in the future, we are looking for expertise to develop case studies for our open access educational platform, Good Food U. So also thinking about the development of curriculum. And that's my email address if you are so inspired to onboard tools to your institutions. Okay, so when I'm talking about the tools, the toolbox that we're offering, what exactly is it? We're focused on providing 4 main tools. These are protocols, standardized ways for extraction, separation, detection of food molecules using high resolution mass spec. This is super exciting, especially for grad students and postdocs who spend a lot of time doing method development. You don't have to do method development anymore. We have done it for you, and you can take these tools to your next lab when you start your own labs. This is super exciting. It's going to save so much work, and the data is going to be so powerful. What makes a lot of our standardization possible are the standardized reagents that we are developing in-house and providing to the world. This allows instruments that might have different models be calibrated and provide really harmonized high-resolution data. We are building our authentic library of annotations to exactly identify what is in food. And then what's really neat is the centralized automated data pipeline, really driven by advances in computer science that allow us to automatically annotate the spectra that's coming off of the high resolution mass spec to provide that quantification. And this just reduces so much time and labor and cost, but most importantly, it allows data harmonization from labs across the world. Rachel, isn't it exciting? So in addition to, as I mentioned, we have 2 sort of types of components that we're looking at. Our core platform is really focused on what is known in food, and then we have a discovery platform of the unknowns in food. This is taking cross-section collisional data. The discovery platform right now is not distributable. We're really just working with 1 lab on this aspect, but we're sending samples to our partners at Vanderbilt University for our discovery platform. So I'm going to show some data, just a little sneak peek both from our core platform as well as our discovery platform. And so this is some data that shows sort of a lot of the work that we've done to date has been to develop these standardized tools. And so here we have over here on the left side, we have a sample, standard reference material of apple sample that we sent to 3 different labs. And this was about 1.5 years ago. And the 3 different labs came back with data, and they each collectively named about 900 compounds in these 3 different samples. But there was only 14 different compounds in food that they each identified that were the same. So we're seeing this huge discrepancy, right? This huge lack of standardization in what different labs, and these are all very high performing labs, in what folks are identifying. So this really drives the need for standardization, again, being able to compare data, and then being able to answer those bigger questions of how is climate change impacting food quality. And so what we've been working on the past year and a half is to standardize this. So it's really taking existing multi-omics tools, building these standardized reagents and having this automated annotation data processing pipeline to enable the standardization. And now when we send data, our samples, data reference material to those labs, we're getting really beautiful alignment. So we have cracked the standardization challenge, and we're really pleased to go to the next phase, which is distributing these tools to labs around the world. Okay, so we are now going to look at some data from our discovery platform, and this is just looking at a handful of samples. We have carrots and apples and strawberries, and about 3 or 6 samples of apples, 6 samples of strawberries, and 9 samples of carrots. And then we have this heat map that is looking at the signatures, different features that are coming off our discovery platform. And there's about 20,000 signatures, right? So when you're looking at like, what are we seeing? There's about 20,000 things off of the data. What's really fascinating is that when we're thinking about diets and dietary diversity and dietary recommendations, we have the recommendation of eating more fruits and vegetables. This data is showing that what is in our strawberry is very unique compared to what's in our apple, and what is in our apple is very unique compared to what's in the carrot, right? So each fruit and vegetable has very unique biomolecules. We know that biodiversity is really the key to resilience, both for humans and the planet. And we can break down that diversity in thinking about diversity at the phytochemical or biomolecular level. And here we're seeing tremendous amount of diversity just in 3 foods. These are just 3 foods, you know, really seeking to understand the thousands of foods on the planet. The next sort of data that I'm going to share with you is data coming off of our metabolomics platform. And this is taking about 100 foods and selecting a group of compounds that we're interested in, flavonoids. Again, we're looking at thousands of biomolecules, but this is just thinking about what's a subset of, you know, compounds that I'm interested in, and then just exploring that data with different questions that we may have. So I'm going to look at this interactive map right now. Sarah, I need help. Oh, perfect. Awesome. Okay. Perfect. Thank you. So this is thinking about different foods on this side, on the right side, and then we have our compounds, our flavonoids on the left side. And what's really, again, neat is we can begin to see the amazing amount of diversity in different foods. And so this is just one way of visualizing the data that's coming off of the platforms. And there's some really surprising data, like when we're thinking about edamame, it's like, wow, it has lots of different compounds that are prevalent. And then we can also begin to then compare between different types of food. So the question was, what's in a tomato? We know some tomatoes are so flavorful, and then those can be linked to the specific chemistry of flavor attributes, as well as different specialized metabolites that provide health attributes. And then we know that some tomatoes just don't quite taste as flavorful, and then we can begin to see that biomolecular structure that's resulting in that. So this is just sort of a fun way of looking at the foods. And if we're thinking about citrus, I was surprised with how much diversity and richness a lot of citrus species have in their flavonoids and limes. So just sort of beginning to, and lemon, so kind of beginning to play with the data that way. And then we can look at it the other way. If we're interested in a specific compound, we can begin to explore what food might that be the most prevalent with. Later on, Alejandra Schrader is going to be sharing just about her planetary health recipes. And we were at a convening recently, and she was sharing how helpful something like this is in developing recipes, especially when you're thinking about substitution of one ingredient for another ingredient, really understanding the biomolecules that are resulting in that variation, and then really thinking about what could be similar. So in addition to developing tools for looking at food, we're also developing the same multi-omics protocols for looking at human serum and looking at those biomolecules in human serum. So then we can conduct empirical studies, cohort analysis to get that empirical data linking food composition and human health. Again, that data is going to be available as a global public good. And then we're also planning to integrate it with other databases, including USDA's Food Data Central, which right now is the world's most utilized food composition database. And then ultimately what we're seeking to do is driving data-driven solutions, empowering stakeholders across the food system to really utilize this data. So that, as I mentioned, could be farmers, that could be crop breeders, those leading recipes or food procurement at hospitals and at schools, as well as chefs. So later on today, we will be hearing from Chef Alejandra in the second portion of our symposium, and she will be leading a tasting as well. So stick around for the second portion of our symposium. I will now pass it over to our next speaker, which is Kat Morgan.